More terminology. Uh, you might have heard the term local minimum versus global minimum. Um, Informally, x star or p star is a local minimum of f of x if the following condition is satisfied. What do we mean? Um, if you take a small enough value, epsilon, small enough perturbation epsilon, and look at the value of f at x star plus epsilon, then the value of f at that neighboring point is at least equal to f star, right? For all small enough epsilon. So this is an informal definition. I don't want to give the precise mathematical definition, which is called an epsilon delta definition. So you can look that up if you'd like. But informally, what this means is that if you're at x star and you take a tiny step epsilon in some direction, the resulting new function value should not be lower. It can be equal to or greater than the function value of at x star, and that's really all we mean by local minimum. And the local part has to do with the fact that you're taking a tiny step away from x star. Okay, so that's called a local minimum. And of course, you want to take the step while being within the feasible step set. Um, right? So because we are searching for the optimal value or the minimum value only within the feasible set or the set that satisfies any constraints you might have on the problem. Okay, so that's local minimum, makes sense. Global minimum means, well, that's the obvious thing where the function value at the global minimum is the lowest possible function value on the feasible set. Okay, any other point on the feasible set has at least that function value. Okay, so if you take a look at this function, this is a range, this is the domain of the function between xa and xt. B and c are interior minima, a and d are boundary minima, a, b, c, d are all local minima. Okay, they are all considered local minima. And then in addition, the point C, which has the lowest value, is called a global minimum, right? Sometimes people might say C is not a local minimum, C is a global minimum. That is not official usage of the terminology. C would be considered in this case both a local minimum and a global minimum. Okay. Okay. Now, of course, we also have local maxima here. E, F, and G are local maxima, where E is the global maximum. Okay, so that's about local versus global minima or maxima. And some functions might have multiple local minima, and depending on the algorithm, we may get stuck in a local minimum, which is not a global minimum. Right? Usually, we want the global minimum, but most methods will only give us the local minimum, and we're kind of stuck with that. Okay, more terminology. This is a terminology. Minimum, min kind of makes sense, pretty intuitive. This is a terminology that you might find in some machine learning books. Let's say argmin. This is read as argmin. Let's first talk about min. So if you minimize f of x with respect to x, that minimum value would perhaps be called f star. But in any case, this is how you use min. Okay. If you use min this way, what you get here is f star, which is the minimum value of f of x. This minimum could be local or global minimum depending on the context. You could potentially use it in either context. Okay. Now argmin, if you say x star equals argmin f of x with respect to x, that really means you minimize f of x and then see the value of x at which f is minimized. That's basically called the argmin, right? X star, the point at which f is minimized, is called the argmin. Okay. Arg is short for argument. where the thing that you put inside the function is sometimes called the argument of the function. Okay, let's talk about optimization in many dimensions, and that's going to be